Welcome to the session number 15 from the playlist of electromagnetic induction. The topic is the Lenz law, and today we will try to understand the Lenz law in brief with the help of these 3 points which I have written here on the board. So here, in order to understand the Lenz law, I have drawn here one simple figure. So this is a conductor which is connected to an AC source, and due to the changing current, now since this is connected to an AC source, so therefore the current is continuously changing. Now because of the changing current, the magnetic field around this conductor will continuously change, and because of this changing magnetic field, there will be a change in the magnetic flux, and the change in the magnetic flux will generate an induced EMF in this conductor, and this induced EMF will produce an induced current. Now, according to the Lenz law, the polarity of this induced EMF, which is producing the induced current, is such that it opposes the initial changing magnetic field. And here the induced EMF is equal to minus n d phi upon dt, where E is the induced EMF, n is the number of turns in the conductor, and here d phi is the change in the magnetic flux. And here minus sign indicates that the direction of the induced EMF is opposite to the direction of the change in the magnetic flux. Now Lenz law is used in a number of applications. So I have written here three this important applications where the Lenz law is used. The first one is that it is used in the electromagnetic braking. It is used in the braking system of the trains. Then it is also used in the induction cooktop. In the induction cooktop, in the cooktop, when we switch on the supply, then the alternating current produces the rapidly changing magnetic field, and because of that, the eddy currents are produced, and because of that eddy currents, the food which is kept inside the induction cooktop gets heated up due to the Joule heating effect. And Lenz law is also used in the balancing of the eddy currents. So these are some of the applications of the Lenz law. In the next session, I will be discussing about how to find the direction of the induced current by Lenz law. So till then, have a nice day. Bye.